Hi, welcome to the fifth problem. The fifth question is the design least recently used cache. The task is to design and implement methods of LRU cache. The class has two methods, get and set. So as per the question, let's break down the question so that we can get the logic. The class, it says a class. The class, maybe let's call it a cache. And it has two methods, get, let's say int of x, and then it says that set int of x, string of y. So what does it say? Get. If it finds key x, then return the value of x. Otherwise, return -1. So it says key and value. So I think I'm going to have a dictionary here to hold my key value pair. Key value, let's call it a data. I'm just writing a pseudocode for us to go through. And then the set says if x is not already present, put it in it. So that means, so I'm going to say data dot try, in order to get, we can just say data dot try get value of x at string. So this will return us the value. I'm just talking the positive scenario, and when it says set, that means we need to add data to try add x comma y. Okay. So if here is the problem. So it says inserted if it's not present. So if I say try add, it's gonna insert and return me true if it added, or it will return me false if it's already present with that key. So when I do that, then the problem statement says LRU cache reaches a capacity. So that means there is something known as LRU cache. It has a capacity. So let's define a capacity. Capacity, let's say call it 5. Which is the capacity? Invalidate the least recently used. The size of the cache should be initiated in the constructor. That means the capacity should be initiated in the constructor. So we need cache constructor where capacity is set. So we shouldn't set it here, so we'll just declare it. It should be a private local variable, private, sorry. Private variable. So it is initialized there. So the problem statement says invalidate the least recently used. So that means we need something to hold this dictionary. So each data of the dictionary should be held by somebody. So in order to do that, the best data structure I think is a linked list. Why linked list? Then, why linked list? Because at that time I can move my data front or back based on the usage. So for example, let's see, I just wrote my input data. The input data, let's say if I say I initiate my class here, oh, I spelled it wrong. I initiate my class here, and then I set value 1, set 2, set says, as we can see, data dot try add, it will keep adding until 5. and then I say print my cache, so it's going to print 1, 2, 3, 4, 5 because, oh, what is print cache? So cache is my dictionary. So whenever I add, I should track this data element also in my cache also. So while I'm adding, I should have a condition saying, oh, if my cache is less, cache.count is less than the capacity, then only add the data. Then only add the data. And my cache should also hold my cache should also hold the reference to the data I'm adding. So what am I going to say is cache dot what am I going to say is cache dot it should hold a reference. So add cache dot add first. I'm going to track my X, which is unique. So that the cache has a reference of my data, and then I'll add my data. So there will be a point when my cache is full. So else if my cache.count is double equal to my capacity, that means it has reached capacity. At this point, I should remove some element from my cache which is least recently used. So that means cache dot remove my last element, and now I have space, so cache dot add first my recently used element, and also save my data dot key value x comma y. So save my data. So what does this do? So I'm saying my cache did not reach the capacity, so track this element in my cache and then save the element in a dictionary. If my cache has reached the capacity, then remove my last element from the cache and then add the element in the first, because that will be the recently used, and add it to my dictionary as well so that it can save and keep it for the future. So I think this is the logic to set so that my cache can track, my data is stored somewhere. So for example, let's see the main. So main says set 1, set 2, set 3, set 4, set 5. At this point, my cache has reached its capacity. If I print my cache at this point, it will be 1, 2, 3, 4, 5. So when I say c.get3, that means get operation. So let's go to the get. So here, if try.get this value, if it's able to find this value, we can do something else. What are we supposed to do? The question, the problem statement says that we should return a -1 if we can't find the value. So we'll return a -1 there. But if we found, try the get value of that. If we found it, return the 2. So we can return a value here. Return value of it. But just returning the value does not solve our thing. The cache also needs to be updated here, because the least recently used, when I say c.get3, the recently used element will be 3. How am I going to do this? So in order to solve this one, I should say I need to store somewhere the newly retrieved element. So I'm going to say linked list node. Let me store this node here. Cache.find X. So it is going to find me that node and store it in my node. And then I'm going to remove that node of X. after I remove the node of X, then I'll add first, because I recently used this node. So I'm going to say add first of X. So this will update my cache. So when I say get me 3, it will come here. Oh yes, there is a 3 in the cache, and there is a data value for it. So it will, then what it's going to do is find the X. Once it's found it, it's going to remove it because it's at 3 position here, and it will remove it and re-add it in the beginning. So when I print my cache, it will be 3, 1, 2, 4, 5. And if I try to add a 6th element, so the cache is full, so it has to remove something. So the 5 is least recently used. The cache will get added at 6, 3, 1, 2, 4. Now when I say get me cache 7, get me 7, it looks in its cache. Oh, there's no 7, so it's going to return me a -1. I think this is how we can implement least recently used cache with 2 data structures, a dictionary, and a linked list. Thank you for watching.